Okay, now I went ahead and multiplied out my elementary matrices, and then I checked. Okay, something we always need to do, to see if the elementary matrix, or the lower triangular matrix I got when I multiplied out my elementary matrices, multiplied by the upper triangular matrix I got when I reduced my matrix, is equal to the original matrix. Well, you see here that it is, but I had an error. I had a couple of errors. Everything worked out fine until I got down to this last number, and when I multiplied this row by the column that I had here, that didn't work at all. Okay, so tracing that out, I just said, okay, well, there's got to be something wrong with this last column here. And I checked out here, and things kind of checked out. I finally got back to here and realized that I think I'd multiplied, instead of multiplying -6 by, still looks like I screwed it up. No. Okay. I have to add 6 times the first row to the third row to get a 0 here. And I inadvertently used a -6 on my -1 here and got 9 down here, when I should have used 6 times -1 and so forth, and I should have gotten -3, which leads to -9/7 here, and now everything works out. So, just one of the advantages of checking yourself. There are a lot of calculations here. I messed up a sign here. Watch for that. So, in the previous video, you can see where I did that, and now you can see what the correction is. Okay? So, anyhow, now we've verified that A is equal to the product of these two matrices. This is upper triangular and this is lower triangular. Now we want to use that to solve this system. Okay, so we can rewrite the system as LU times the XYZ is our 3, -7, 5. So that XYZ is LU inverse times -3, -7, 5, and it's not -3, is it? Okay, yeah. Now it's -3, okay. Just change it up here. Which equals, what's LU inverse? This is U inverse L inverse. Remember that we have to switch the order, and remember why. Remember why multiplying this by LU gives us the identity, whereas if we did L inverse U inverse, it wouldn't give us the identity, except in rare cases where the matrices commute. Okay. And I'm not even sure they could commute in this context, but I suspect that they could in some way. I haven't played around with that to see if it's even, if we can get a handle on that question. Doesn't matter. Okay, so there's our solution equation. Now we could invert L and we could invert U, but we don't do that. Okay, first of all, let's let Y equal whatever we get when we do L inverse times -375. Here's the trick now. Then Ly equals -375. Okay? And we can solve this easily by back substitution, or forward substitution in this case. Okay? So Ly is what? Well, here's L, okay? And let's let Y equal Y1, Y2, Y3. So that multiplying L by Y gives us it gives us a matrix equation, but we can see that when we multiply that and set it equal to this, we get the two equations. 3y1 equals -3. Negative y1 plus y2 equals, where is it, 7. I think it was -7 until I forgot to write the negative, okay? So that would be -7. And then we have, from here, -6y1 minus 6/7 y2 plus 1. y3 equals 5. Well, that can be solved by forward substitution. 3y1 equals 3. So we have what? -1 plus y2 equals -7. Which implies that y2 equals -6. Now we know y1 and y2, we can plug in to this equation. We have -6 times 1 minus 6/7 times 6 plus y3 equals 5. So we get a solution for y3. And we'll work it out, it's in sevenths. That's -42/7. And this is -36/7. So that's -42, -36 is -78/7. 5 is 35/7. We add, what did I just get? 42 and 36, which is 78 to the 35, and we get 113. So I think y3 is 113/7. Question my mental arithmetic, question it a lot. Okay, so let's just check that out again. That's -36. At -36 and -42 is -78. Yep. And add that to 113, we get 22, 13, 25. Oh, come on. Losing my numbers, okay? Might be 123, I don't know. Anyhow, I'm just going to illustrate this. Then, U inverse if this is right, times 1 -6 113/7. So U times X, Y, Z equals this. U is upper triangular. Right there it is. There it is. So this gives us the equations X minus 2/3 Y minus Z equals 1. Okay. Second row times a column equal to -6 gives us 7/3 Y plus 2Z equals 2. I didn't leave myself enough room down here, but I can really do without that last row, which is just a lot of scratching anyway. When I was multiplying the elementary matrices, and I never really even talked about that, because you can certainly multiply those matrices, okay? So, and then our third row times X, Y, Z gives us Sorry. Yeah, third row is negative 9 to 7c equals 113 over 7. So what? From this, we get assuming I'm correct here, that z is then negative 113 over 9. So we plug that in here and we find y. And then we plug that z and that y in here and we easily find x. Now I'm not going to complete it, but that's the process of using LU decomposition. Check my arithmetic on that 113 seconds. I think the rest of the arithmetic might be right. That might be right. Doesn't look it.